Greetings and welcome to the United States Transhumanist Party Virtual Enlightenment Salon. My name is Gennady Stolyarov II, and I am the chairman of the U.S. Transhumanist Party. Here we hold conversations with some of the world's leading thinkers in longevity, science, technology, philosophy, and politics. Like the philosophers of the Age of Enlightenment, we aim to connect every field of human endeavor and arrive at new insights to achieve longer lives, greater rationality, and the progress of our civilization.
Okay, new presentation. Gennady Stolyarov, a regular participant in our conference. There is a poster on the wall over there with some more details about Gennady. Of course, there will be another one poster, electronic, at the end of the conference with full details, because updates are coming permanently. Gennady is having a lot of activities. Now he will speak about the progress of artificial intelligence. But also, I would like to announce that in advance, he is author of Left Game, and I will speak about Left Game immediately after Gennady in order to make sure that he will be able to hear my presentation, because in Nevada at the moment is midnight. So not to force Gennady to stay all night awake. Later on, we will continue according to the time zone. Gennady, you have the floor.
All right. Thank you very much, Angel. And it is an honor, as always, to present at the Vanguard Scientific Instruments in Management Conference. And hopefully you will recognize the timeliness of this topic. Artificial intelligence is advancing rapidly. And I think it is important, especially as transhumanists, as futurists, to bring some balance, nuance, rationality, and proportionality to a conversation that I think, especially these days, is overly dominated by both hype and fear. So today, I hope to point out both the immense progress that AI has been making, as well as to assuage, let's say, some of the more extreme concerns about artificial intelligence completely displacing humans or making humankind, human existence, human worth, and purpose obsolete. Because I certainly do not think that AI will have that effect. I think AI can have some disruptive effects, clearly, and we need to be aware of what those are. But right now, it seems all too often the conversation is dominated by a combination of hype and doomsaying. How many times have all of us heard the following statements or something along these lines, that AI will take all jobs and make human workers obsolete, that artificial general intelligence, AI that can learn and perform potentially any task without being specifically trained to do so, is imminent. Some have posited there will be an AI singularity by the year 2027. So now less than a year and a half from now, based off of large language models, which is essentially the current state-of-the-art technology for building AI systems that most members of the public are familiar with, like the chatbots, ChatGPT, Grok, Gemini, Claude, or the AI art generation platforms like Midjourney or DALL-E. Grok has a built-in AI generation platform as well. Some people say because AI is able to synthesize such vast amounts of knowledge in so many disciplines and provide answers, summaries, overviews that at least seem plausible to a layperson, you will never need to study or learn anything again because of AI. And on the other hand, some people will say, well, AI will make you lazy. It will make you over-reliant on it. Your brain will atrophy because of AI, because you will outsource too many of your cognitive tasks to AI. And so that will spell the doom of humans actually doing anything meaningful, and it will lead our species to decay and deteriorate. Some people will say AI will inevitably escape all human safeguards and destroy humanity. It's Eliezer Yudkowsky's set of talking points that if anyone builds an artificial general intelligence, everyone will die. No matter what we do, we are doomed. And the best we can hope for, some will say, and sometimes these people even portray themselves as being optimists, as AI replaces us or even ends our existences, we can hope that AI will be a worthy successor to humanity. Now, I don't buy any of these talking points. I think such statements stoke sensationalism, and they do not advance anyone's well-being. Well, maybe they advance the momentary fame and visibility of those who are making these kinds of claims. And I think, unfortunately, a vulnerability of human psychology is that people tend to fall for the more extreme statements often because we evolved in an environment where if we see something behind a bush in the distance, well, we can assume that it's something benign, or we can assume that it's a predator. And if we assume that it's benign and we go about our way, well, maybe we'll survive, or maybe it actually is a predator and it will eat us or do something else to end our existences. So our ancestors who survived tended to assume that it was a predator. And I think with any new development, including AI, people are already primed through their, let's say, evolutionary baggage to make that kind of assumption. But I think it's important to consider, what are all of these statements missing? Why are they incorrect? And at the same time, why is it so tempting for so many people to make these kinds of statements, both in terms of AI hype, that AI in the course of a few years will just displace everybody and make our species obsolete, as well as AI doomerism, which states that AI will become so powerful that it could eradicate the human species, and some people will assign extremely high, what they call P-doom, like 99% that humankind will become extinct. So I will say my P-doom, for what it's worth, is somewhere less than 0.00001. But I think both the AI hype camp and the AI doom camp misapprehend what the distinguishing advantages of humans actually are. And I don't fault them for doing that, because for millennia, human philosophy, discourse, literature has actually taught us that these are among our most distinguishing advantages. But for example, are humans uniquely the best at creativity? Well, we've seen AI systems that can create some impressive art and music, and sometimes those creations seem no less original than the ones that humans have come up with. And this observation even precedes the current generation or recent generations of models that can create art and music. There was a composer named David Cope, who unfortunately died earlier this year, who created AI-generated music in the style of various composers going back to the 1980s and 1990s. He had AI systems called EMI, Electronic Musical Intelligence, and Emily Howell that were able to both compose in the styles of historical composers and create some interesting sounding original works. So AIs could be creative, I think. Are humans uniquely superior at logical reasoning? Well, we see many AIs, including commonly used large language models, that can already reason better and more comprehensively than most humans. Certainly, they are less likely to fall prey to very common fallacies or common propaganda techniques. What about manual dexterity and spatial orientation? Those are actually more challenging skills for artificial systems to learn, but some impressive humanoid robots are emerging, and various companies are at work on developing these robots. If you've seen the videos from Boston Dynamics, for example, or if you've seen any of the prototype household robots that are being demonstrated now. Certainly, they have a way to go before they can navigate physical environments with the same fluidity and dexterity that humans can, but clearly there doesn't seem to be a hard limit to these capabilities. What about computation and information processing? Well, clearly even computers that have existed for decades are better than humans at these, and AIs can also far surpass humans at these tasks. Now, what about compassion, empathy, and emotional intelligence? These have often been presented as unique human attributes, but some people have engaged in dialogue with large language models, and it seems, at least in many cases, that those models are able to offer responses that those people find to be more compassionate or to, in some ways, be more understanding or more reflective of their situations than responses of humans. I think sometimes even people may be misled, for instance, into using AI for purposes of therapy, where the large language models are actually not sufficiently advanced or tailored for that purpose. But people do find some of their responses to be emotionally compelling. What about ethics, morality, and wisdom? Well, I would contend that perhaps any one of today's commonly used AIs would do a better job than today's crop of dominant politicians, business leaders, and cultural figures. And I know that's a low bar to exceed. However, I will make that observation. I would rather have an AI as president than the presidents or other national leaders that currently dominate the world. So where does that leave us? So AIs have previously defied predictions of what AIs could never do. And this is now a famous cartoon from Ray Kurzweil's 2005 book, The Singularity is Near. And this character at the desk is meant to represent the human race. And on the wall are all of the statements of what AI cannot do or what only humans can do. And on the floor are all of such previous statements that have been discarded. But the human race continues to write new statements. But what is interesting about this kind of critique and these kinds of statements that AIs seem to essentially defy the limitations of, these are statements about specific capabilities like playing chess or improvising music or understanding speech or translating. So these are specific tasks that it's alleged that AI can never do, and AI systems are developed to do them. But these are not so much broader attributes of the kind that I will be discussing. And this is also timely because it was one of the key areas of focus in our 2024 election campaign, where our presidential candidate, Tom Ross, had a major emphasis on the need to focus on attributes that cannot be coded or automated away. So it is possible for there to be major disruptions in the job market because of automation and artificial intelligence. In the past, when new technologies have been developed, it is true that certain professions, certain lines of work, certain tasks were made obsolete. Humans no longer needed to perform them, or what those tasks looked like became very different. So one of his 3 campaign initiatives, the Earthling Initiative, was intended to prepare Americans for the technological and economic singularity. I think it's more of a long-term endeavor to engage in such preparation, but it's quite worthwhile to think about what truly makes humans stand apart. What human skills, faculties, attributes truly are irreplaceable and will not be made obsolete by AI anytime soon. And some of this transition could indeed involve support for people who are temporarily displaced from their jobs. Ideas like a universal basic income or retraining initiatives, educational tools, harnessing AI for the purpose of helping humans build new skills or discover the skills that they already have that perhaps were not explicitly articulated or deployed in such a way as to enable those humans to thrive. Because if we get this transition right, AI and automation can bring about immense improvements to living standards. So one of Tom Ross's many advertising campaigns focused on this idea of paradism. So you can see here a post-laundry automated utopia, or a post-vacuuming automated utopia, or a post-mowing automated utopia, where the robots can do all of these tasks so that you can enjoy post-scarcity automated weekends, and a robot can come by and charge your electric vehicle while you are engaged in whatever activities bring you meaning and fulfillment and enjoyment in your day. So that's the kind of future that we want. We don't want a future of hype and fear. We don't want a future where humans are arrayed against AI. We want a future where humans coexist with AI. And that means we need to know the distinguishing advantages of AIs, but also the distinguishing advantages of us, humans. So the arrival of artificial intelligence in many spheres of life has caused fundamental rethinking of this question. What does it mean to be human? Because clearly what traditional philosophies, conceptual systems, or colloquial understandings have taught us as being the distinguishing advantages of humans are perhaps less exclusive than they have historically seemed. However, other attributes that were overlooked or taken for granted actually turn out to be essential advantages that I don't think AIs will possess anytime soon. So what are the actual advantages of humans? I thought of 10, and interestingly enough, I asked both Grok and ChatGPT, what do you think of this list? Are these actual advantages of humans over AI systems? And both Grok and ChatGPT agreed with me on each of these points. For what it's worth, but I think these points will stand on their own, irrespective of what AI systems have to say about them. But I think one fundamental advantage of us humans that most people just, let's say, let exist in the background of their lives, but don't really verbalize as explicitly, is simply the fact that we have persistent identity or subjective continuity of vantage point, what I call the I-ness. So just the mere fact that I perceive the world as me, and this is a continuous perception, a kind of process continuity of my existence, which builds upon itself. And AIs don't have that. So every time you run an instance of a large language model, it's a different instance. And it may draw on a common knowledge base or training data set, but every time a different user interacts with an LLM, it's not the same entity with the same continuity. It's a mistake to say, well, ChatGPT is a singular entity. No, it's just code that gets deployed in similar ways, but with different details to different people. Likewise, AIs have relatively short context windows. If you engage in a conversation with one of today's large language models, the context window, what it remembers, tends to persist over a few tens of exchanges. It can vary. The context windows have grown over time. But for humans, the context windows span decades. We have memories that go back to some of the earliest years of our lives. Although they are imperfect, we tend to remember the moments or ideas or experiences that were at least understood by us to be the most important. Furthermore, we can gather empirical evidence autonomously through varied physical senses. This is not the case for AI models that generally receive training data. Maybe they have access to the internet, but the vast majority of them are not embodied. They cannot just go out into the world and learn through seeing, touching, hearing, smelling. They could receive descriptions of what that sensory experience is like, but this is not anywhere close to actually having that experience. So the way in which they will reflect that is a kind of faded simulacrum of what we can fathom directly and in extreme richness of detail just by looking around and engaging our other senses. Also, humans have tremendous versatility in learning almost anything, at least roughly to a first approximation. If you consider how a young child learns and the curiosity that a young child displays toward various domains of human endeavor, AI systems can only learn in domains where they are trained to learn. And a child might not become extremely good at something for a while, but at least they can take the first steps into almost any domain. Humans have resilience and extreme adaptability, even in the face of severe survival pressures, in the face of wars, natural disasters, poverty, all sorts of suboptimal conditions of life. They are able to figure out responses that will at least get some of them through. And some people, even with imperfect and inconsistent responses, will have generally the right responses to any given set of pressures. And hence, human beings have survived a variety of cataclysms. AI systems require environments that are finely optimized and tailored to their existence, and they can function tremendously well within a set of background conditions that are actually quite fragile if one has studied history to any significant extent. So in any sort of crisis or cataclysm, my bet would be that humans will outlast AI systems. Also, humans have the ability to implement rough heuristic solutions when precise approaches are not available or too costly. Sometimes AI systems will overthink and get stuck in infinite loops or try to devote undue amounts of energy and resources to problems that could be solved, perhaps again, not as precisely, but in a manner that's good enough to suit the needs of the entities that are actually affected by these problems. And humans tend to have a decent grasp of when a heuristic solution is good enough. Also, humans have undertaken intuitive integration of life experiences, and many of them are unspoken. They're tacit generalizations drawn from numerous situations whose lessons cannot be easily verbally explained or written down. But that essentially is what intuition is, and it's formed over the course of a lifetime. Sometimes one cannot rationally explain, simply because language is deficient, why one may think that in a given situation, certain consequences might arise. Maybe one might have an uneasy feeling about a particular situation, and that's an intuitive integration from having encountered many similar situations in the past and perhaps catching on to certain clues or context that the AI system, especially if it's not embodied, it doesn't have the human senses or long context window, just wouldn't have a reason to perceive that way. And also common sense. Well, common sense is not so common among humans, but it's far more prevalent among humans than AIs. So sometimes humans, again, will pick up on the context and will recognize a particular solution is suitable or it's not suitable. And the AIs will simply evaluate the solution on some set of, let's say, technical merits or criteria that may or may not fit. Humans also have an advantage, and I think this is an advantage of satisficing over optimizing. So satisficing is knowing when a solution is good enough, even if more work could be expended to make it marginally better. And humans definitely have inner experience. We know it because we ourselves as individuals have inner experience, and unless one falls into what I think is the very fallacious mindset of solipsism, I think it's reasonable to conclude that entities with very similar biological makeup to ourselves will also have that inner experience. Maybe someday AIs will have inner experience as well, but certainly current large language models do not have the equipment for inner experience. And inner experience is important if we want to be around entities that actually care about us, at least sometimes, rather than just mimicking the appearance of doing so. So the AI therapists, well, they may give some good advice sometimes if they're configured properly, but do they actually care about the people interacting with them? Well, they don't have the inner experience to be able to care. So this is interesting too, because some AIs may differ as to whether or not they have common sense. Again, I asked Grok and ChatGPT, do you have common sense? And Grok said, yes, I've got a decent grasp of common sense, enough to navigate everyday situations and make reasonable judgments based on practical knowledge. I'm built to understand the world in a way that aligns with how humans think, so I can usually pick up on the obvious stuff and avoid the absurd. But if you throw me a curveball from some niche corner of human experience, I might need to lean on my data or ask for a bit more context to nail it. So Grok does acknowledge that limitation. And later on, Grok said, well, yes, I have some simulacrum of common sense, but humans could still be better at common sense. ChatGPT, I think, was a bit more accurate in the initial characterization. I can apply reasoning that often looks like common sense, drawing on patterns from everyday life, language, and logic. For example, if you say it's raining and I forgot my umbrella, I can infer that you might get wet. But unlike a human, I don't have lived experience or gut feelings. My common sense comes from recognizing patterns in how people usually talk and reason about the world. That means I can sometimes miss things that would be obvious to someone who has been in these situations personally. And they all then ask you a standard question. Well, do you want to explore this further, etc.? And I think sometimes that formulaic way of answering questions is also more characteristic of AIs, less characteristic of humans. So there are also problems that humans are still uniquely good at solving, and these are abstract cognitive problems. Usually these problems involve combinations of skill sets, for example, pattern recognition, spatial perception, or logical reasoning, that AI systems can tackle individually fairly well, but they fail to properly combine, or importantly, recognize which skill to apply at which time, whereas again, humans have the intuition to do this without really that much difficulty. So Francois Chollet created this set of problems, and there are three generations of these problems called the abstraction and reasoning corpus ARC-AGI. So the idea is if an AI system can be developed to solve these kinds of problems, then it could make a plausible claim to being an artificial general intelligence. There's an interesting article on this called AI's Achilles Heel, Puzzles Humans Solve in Seconds Often Defy Machines, from the Scientific American. I would encourage you to read that. And also you can try all three sets of the ARC-AGI problems at arcprize.org. So to test what is an AGI, one should have a definition of AGI. So this framework is based on the definition that AGI is a system that can efficiently acquire new skills outside of its training data. Francois Chollet wrote that the intelligence of a system is a measure of its skill acquisition efficiency over a scope of tasks with respect to priors, experiences, and generalization difficulty. And he wrote this in 2019, so before the current crop of large language models. No current AI system is anywhere close to embodying those characteristics. For example, we have impressive chess-playing AIs that can beat humans. No chess-playing AI today can learn to drive a car without being taught. We have impressive AIs that can drive cars, though. I've ridden in Waymo self-driving automobiles. I would trust them to a greater extent than I would trust the vast majority of human drivers. But no self-driving car AI can learn chess without being taught. A large language model cannot learn to fold laundry. How could it? Even to the level of a current humanoid robot. least without being taught, without being put inside a robot and explicitly given the routine for folding laundry. But a humanoid robot that's taught to fold laundry cannot learn philosophy, even to the level of a current LLM, again, without having a database of philosophy texts and ideas uploaded into it. So none of these are AGIs. I don't see a path that is very directly apparent from these current systems to an AGI. I tend to agree with Peter Ross that a different architecture may be needed to get to a true AGI. But let's see an example of an ARC-AGI problem, and this is just a problem that I selected at random, but it's a very interesting problem. So on the left-hand side and in the center, you see examples of inputs and outputs. So what happens when you have this figure here, the red square with a dot in the middle, and then you have essentially these 8 black dots around it. And you see the output, well, it's the same, but it's filled with a blue color. And you see another example of an input where now there are more black squares in the middle. And you see now there are 2 columns that separate the center dot from the square here. That gets filled with yellow. And you see 2 more examples. Now, these will, I think, challenge an AI because now you've got multiple shapes, but really there's only one new rule to be inferred from this, and a human can very readily infer that rule. It's about filling this green space here, where there are 3 black columns between the frame of the square and this central red square here. So how do you fill this? That's the problem. And I think we humans can tell the answer very quickly if we understand the given condition. So this one will be green, this one will be yellow, and these 2 will be light blue. And that is indeed the solution. No AI can solve this today. So why will humans remain needed in the workforce? We talked about some general human attributes that I think will not be replaced by AI anytime soon. How do they apply in practice? I strongly think that the future is not one of AI replacing humans, but rather one of humans who use AI, sometimes replacing humans who do not use AI. So perhaps the nature of the tasks we will perform with the aid of AI will change or evolve, and those who learn to use AI effectively will keep up with that evolution. Hallucinations will continue to be a persistent problem. Either they're inherent to the design of large language models, and AI experts such as Peter Voss and Rafi Kumsieh, with each of whom we've had virtual enlightenment salons that I have hosted at the US Transhumanist Party, or at the very least, these hallucinations are very difficult to extricate. And you always need to be vigilant. You always need to know how to pursue certain inquiries further or design prompts that are less vulnerable to hallucinations. And unlike human confabulations, which often provide emotional or circumstantial clues that something appears to be off, the LLM hallucinations will appear plausible to the uninformed reader. So unless you're a subject matter expert, you might miss the fact that the AI has hallucinated. And therefore, deep subject matter expertise will become more essential than ever to differentiate usable AI-generated content from flawed or hallucinatory content. So the more AI is used in, for instance, scientific research or writing reports, writing about any subject that involves facts or complex concepts, the more precise you need the answer to be, the more you will need subject matter experts to check the output of the AI. And also human editorial and curation skills are essential to enable the AI-generated content to be deployed in practice. I have seen now numerous instances of AI-generated content, which seems to be 95% to 99% fine. But the other 1 to 5% if it were allowed to remain as is, would be clearly seen as absurd or inaccurate or even, let's say, damaging to the reputation of the person or organization that deploys it. So you need a vigilant eye, you need a skillful editor to detect which 1 to 5% to remove or replace, or ask another AI to provide the actual good content there. And also, if you have a larger project, an AI cannot create your entire project for you. What specific pieces of AI-generated content belong in a work product? In what sequence? And how do they relate to other AI creations and human creations? Because I think a lot of work products, outputs, they're not going to be exclusively human or exclusively AI. They'll have elements of both, and which elements work best in which places, in which projects, that will be a human skill set to determine. And then human prompting skills will be necessary to even generate decent AI content in the first place, because we know even with computations, if you ask an AI system, a large language model, to multiply two large numbers, the answer it will tend to give you will be accurate to about 3 significant figures, and then it will be inaccurate from that point forward. However, if you ask it to give a precise calculation, or if you challenge its first attempt, it will engage a subroutine. Maybe it will run some code that will actually give you the correct answer. So it tries to give you a heuristic answer that is wrong, and then if you prompt it in a different way, it has the ability to give you the correct answer. And then AI-generated prompts for AI. Some people will say, well, human prompting is not going to be around for long because the AIs will be able to make better prompts. But that misses the point, because the AIs don't know what they don't know. And in particular, they don't know the needs of the users or the standards by which the users will evaluate the output. So those unarticulated needs, and I think we at this conference or in the general transhumanist futurist space are quite articulate individuals. Most people will not have that kind of patience to articulate what their needs are in such a way that the AI will predict it. So I think human prompting is here to stay. And then also, in any given organization, most knowledge is tacit. And even in any given person who has worked in a particular role for a long time, it is a distillation of years of experience. It's often not written down in a procedure, manual, or other legible format. Most knowledge is distributed across persons. So different people may hold different pieces of knowledge that is essential to making an organization work. And AIs also may generate valuable knowledge and insights, but those will be different from the knowledge and insights that humans can generate. AIs will have some pieces that are needed to make an organization work, but many different humans will continue to hold on to other pieces. So it will be a kind of heterogeneous landscape of knowledge and experience. And similarly, while AIs may generate impressive writing or artistic output, humans will continue to be able to generate writing or artistic output. It might not be better, it would just be different by virtue of these human minds being different from, let's call them, the minds of any AI systems. And this difference will continue to have value, just like differences among humans that lead to different outputs have value in our society today. And then persistent human identity contributes to the formation of institutional memory in an organization, and that institutional memory is crucial. I've seen what can happen when institutional memory is lost, for instance, through rapid personnel turnover. And I think a lot of companies in Silicon Valley today are making huge mistakes by laying off thousands of workers under maybe the excuse that AI is rendering those jobs obsolete, because I don't think that is actually what is happening, but they're losing a lot of that long context, a lot of that institutional memory. And institutional memory is passed on gradually in an organization, often without being cataloged or proceduralized through everyday interactions. And some people will say, well, okay, if you have experience, if you have subject matter expertise, you will remain valuable. But what about entry-level workers? Can't AI do the simple entry-level tasks that are often delegated to these individuals? But I would say even entry-level jobs will have value, because existing decision makers should value the continuity of vision and implementation. Ultimately, people in their current positions in an organization, even in top leadership positions, aren't necessarily going to be there always, aren't necessarily going to want to always be there. Maybe the transition is something they welcome if they want to go on to do other things, but then they would wish to preserve what they have built. And the best way to achieve that continuity of implementation is to train and mentor one's eventual successors and to secure their loyalty by treating them well. And I don't think an AI quite would do that task. At least I don't think an AI could be programmed to have that continuity of vision over the course of many decades as contrasted with a human successor. So now we come to executive decision making. While AI could plausibly, as I said, replace world leaders and CEOs of large companies, and I'll explain why, with little ill effect, I think it would take a long time for AI to be able to replace a competent small business owner. And this seems like a paradox, but I think we understand that running a business effectively requires general intelligence, paying attention to developments in a large number of disparate domains, calibrating effective responses under various constraints. So narrow AI can't do all of that. It might be able to assist in some specific tasks. But even for effective project management or coordinating social interactions, those kinds of capabilities are required. In recent years, there have been various attempts, especially when the first really impressive large language models came out, to run a business based entirely on the advice of AI systems. So do whatever the AI system says. And even for AI systems that drew upon vast knowledge bases, those attempts failed miserably. Why is that? Because the AI systems could not grasp what was happening in real time that affected the opportunities and constraints of that business. So the AI system might say, well, I recommend that you purchase so much of this input for your business. And in theory, that may be a reasonable recommendation. But the fact is, the market for these inputs is changing consistently. And maybe the AI was giving you advice based on data that it ingested 2 years ago, and you can't find those inputs today, or what you find is really different. And that's just one possibility out of millions of ways in which the AI advice could be misaligned with real-time reality. But why can AI replace world leaders and CEOs of large corporations? Because those people are similarly removed from the real-time reality on the ground, because rigid hierarchical structures keep them away from that reality through often intentional information filters and people who don't want to give them bad news and people who act as screens for them, that they really often exist in a bubble. And so they could be more readily replaced by AI than active managers who actually get things done. So you could have a world leader that is an AI and that gives informational speeches, that articulates a general agenda for the country or a large multinational corporation, but you'll need human implementers to actually realize any of that vision. So to conclude, I think this is an idea that anybody can apply to make sure that one endures and remains valuable in an era of increasing deployment of artificial intelligence. I think the greatest value a human being can bring is in their individual life story and the way in which this story influences everything that human does, because no AI can capture that fully with the same depth and nuance. And leveraging the unique attributes and advantages derived from one's life story is a way to reliably differentiate oneself from AI and remain resilient to any disruptions involving AI. And I say this knowing full well that there are attempts right now to create AI avatars of people, including people who are alive today, and that will continue to happen. But the fact is, the AI avatar only knows what you give it. So your writings, sure, even say informal communications or notes, but can an AI avatar have every moment of your lived experience and capture every nuance and really anticipate how you would react to a novel situation? I think an actual human will always have an advantage in that. And furthermore, humans are drawn to the stories of other humans, and this will remain the case even if AIs become technically better storytellers. Sure, the AIs could entertain us, but if we're looking for meaningful stories about people that are relevant to us as people, I think we will continue to need the stories of other people for that purpose. So hopefully I've dissuaded some people who think that doom of any sort or human obsolescence of any sort from AI is imminent, but certainly a lot of change and a lot of transitions are going to come. And the Transhumanist Party tries to tackle these kinds of transformations and figure out how they can be harnessed beneficially. So I would encourage anybody to join us from anywhere in the world. Membership is completely free at transhumanist-party.org/membership. Or if you're apolitical, we have an affiliate organization called the Transhuman Club, which is more about art, education, discussions of the sort, technology as well. So please visit our websites, visit our weekly virtual enlightenment salons, and let's continue the conversation on these very important changes that are happening. How can we ensure that the human species remains, I think, in a deserved place of relevance and continued improvement of our conditions? Thank you very much.
Okay, thank you, Gennady. Thank you very much for your presentation. That's one. Second, next step is to open discussions. There is a number of people with AI background at the moment in the conference on different branches of the area. I see doctoral students, postdocs, and actually David already started discussion in the chat. So please, your questions and comments for all, of course. Okay, questions and comments. Anton?
Okay. No, I just wanted to say in the talk there was this mention that, for example, to play chess, it should be explicitly trained to play chess. But actually, if we look into this AlphaZero and AlphaGo, they were trained on playing against itself. So that means that if the task can be formulated as a reinforcement learning setting with more or less clear value function, and for chess and Go, it's pretty easy to measure whether you won or not. Actually, you don't need the human training data. The issue is that for like more complex real life, it's extremely hard to come up with appropriate reinforcement learning, and you will see all types of value function hacking when it tries to cheat the system. That was just a comment.
Yes, thank you. And I think that's a fair observation. I do think that the AIs that are trained to, let's say, excel in domains where the criteria of success are very clear, like chess and Go, are trained in a fundamentally different way from the AIs that operate in the physical world, because those AIs need to take in a lot of data from sensors. So let me give an example. It seems like Tesla's self-driving car AIs are failing right now because of the decision that Elon Musk made to not use LiDAR technology and rely solely on the cameras of those vehicles. So it seems that there's insufficient empirical input there. But at the same time, it seems that those AI systems, the successful ones like the Waymo systems, for instance, even though they take in all of this input, they wouldn't teach themselves an abstract task with well-defined criteria of success. So this is what I mean when I observe that they cannot cross domains very readily. Now, if there are two activities that are somewhat similar, maybe chess with different rules, like there's three-dimensional chess that you can sometimes buy sets of three-dimensional chess. Some have even devised like rules for four-dimensional chess. Maybe a system like that could learn those games, but that's still very proximate. I am still skeptical that we're anywhere near a system that can go from being trained in just one domain or not being trained at all, and somehow mastering an entirely different domain that requires different skill sets, almost a different framework of functioning that we have within our cognitive and sensory equipment to learn, even from a very early age. So this is a way, again, in which we're just more versatile than the AIs.
Well, talking about, for example, 3D world tasks, actually right now, what many expect is that because a lot of synthetic 3D data that is simulated in 3D worlds, soon we will see a lot of so-called world models trained in synthetic 3D generated environments, then will transfer learn based on limited data a real world environment. It's actually happening in robotics when they do pre-training with post-training steps that they could perform well. But overall, what you raised about humans is that what we know is that humans are way more efficient because they have less training data than AIs. So that's what can be improved. And there is an architecture, I think it's by Meta, and they are like in the FAIR lab, they are training these JEPA-based models that try to simulate human learning by this embodiment in the virtual kind of body and trying to generalize among multiple modalities. So it's slower than multimodal LLMs, but I think in like some numbers of years, actually, it would be coming.
Very interesting. And I could see how that could give the AI system some limited embodiment. I remain skeptical that they could replicate all 5 of the main human senses and the various nuances of them. I think perhaps vision might be the easiest, to some extent maybe hearing, but what about taste, smell, touch? Those require some, let's say, more advanced systems, unless those 3D worlds also have like haptic interfaces and these AIs could somehow experience taste. There will still be limitations. I think, again, these are steps forward toward the kind of general purpose AI, which I think will be feasible at some point. But my inclination is to think it will be feasible in the 2040s, not by 2027, as some will assert. But to be sure, steps are being taken in that direction. And I actually welcome that kind of progress. So unlike people who say, oh, AGI or singularity is coming by 2027 and we need to be afraid or worried, I say, well, I don't see signs of the AGI singularity coming soon. And I'm a bit sad about that because AGIs could solve a lot of the problems that our species faces. Clearly, some thinking should be dedicated to ensuring that they follow moral constraints the way humans are taught to follow moral constraints. But I think that problem is solvable. Still, if AGI comes sooner, and I think the soonest it could arrive would be next decade, the 2030s, I will be pleasantly surprised. I want to be pleasantly surprised in that way.
Okay, I'm also optimistic. Thanks.
Okay, thank you. I would like to give a positive example of Anton and Livia for foreigners physically visiting our conference already for the second time. Anton is having a permanent chair on the table. So I do invite again all foreigner participants to visit, if not this, then the next Ravda conference. Evidently, I have to make a more active advertising campaign. I will correct for the time. Anyway, more questions and comments. Are there more questions and comments? David, would you like to add something in addition to what you already put in the chat?
Well, my first question is, how long do we have? Because I think this conversation could easily happen
today, so discussion is more important then the time.
Yeah, because we might continue this discussion until at least 2027, I think. It's a really important set of ideas to figure out what is unique about humans. I don't agree with most of the list that Gennady presented. I think the list that Gennady presented of 10 items probably splits into 3, as I said in the chat. Some of them I think AIs can already do quite well, like they're not all rigid optimizers. Some of them are quite good at satisficing. The bulk of the items come down to, well, the AI is not yet generally intelligent. It doesn't have common sense. It doesn't have the ability to transfer learning into totally different fields. And I accept that we don't have that yet. But I do think that we could have AGI quite soon, not just by scaling up large language models. That's clear that's not by itself going to succeed, but it's by joining large language models together with other elements, such as what Peter Voss is developing, or there's all kinds of initiatives that Ben Gutzel and others are trying, which include neural networks as part of the overall brain, but there are other interesting developments. And these other interesting developments, by the way, can be accelerated by using neural networks to help the researchers. So I think it is possible. It's unlikely, but it is possible we could have general intelligence by 2027, as some people have suggested. What remains, however, is there is 1.5 items in Gennady's list, half of the first and maybe the last one, where I think it goes beyond general intelligence. It goes to phenomenological consciousness, the sense of an inner eye rather than just the appearance of an eye. And it's not clear to me that anything that AI researchers are doing will get there. It could be that it emerges naturally, unexpectedly, in the same way that other aspects and characteristics of LLMs emerge unexpectedly. But I think it's also feasible that so long as AI models are based on anything like the hardware they're currently running on, these systems won't be phenomenologically conscious, and to that extent, humans will have a unique value going forward. But still, there are reasons to worry. The reasons to worry are that the AIs, even though they are not phenomenologically conscious, they may still be used by ill-intentioned people, or by naive people, or by over-optimistic people, or by people who are deeply frustrated and hate the world, whether it's Hamas terrorists or other kinds of terrorists, whether it's people who are just fed up with the world because of other reasons. They could use AI for terrible purposes, which is why I think we need to prioritize addressing these questions in advance. How do we ensure that AI remains under our control? And that also means remaining under our understanding. And in neither of these are we doing a good job, which is why I am concerned, which is why I have said that my PDOOM is about 5/12, which sounds like a strange number, but I give the reasoning behind that in some of the articles I've linked to in the chat. Now, as I said, I think this discussion could easily go on to 2027, but I'm happy to hear Gennady's replies to some of these points at least.
Yes, thank you, David, for the analysis and the critique. And I do hope that in many respects, the conversation will continue through 2027, and there will be various installments of the conversation. I will, first of all, outline points of agreement. So there can arise real problems with humans using AIs or humans designing AIs for certain tasks where there always needs to be not just a human in the loop, in my view, but a responsible and ethical human in the loop. So for instance, I think it would be highly ill-advised and dangerous to have any sorts of autonomous weapons systems that make the decision to kill humans or destroy infrastructure without an explicit human sign-off, or even in a situation where there is an explicit human sign-off, but the humans have learned to really offload that cognitive responsibility to the AIs. And we've seen that in certain contexts already beginning to happen. So I think whenever there is the possibility of an adverse effect on a human being, and this could be in the context of war, or it could be even in a much more let's say, mundane contexts, say financial decisions, if there's a situation where somebody could be charged a higher price, somebody could be denied a loan, somebody could be denied an opportunity of some sort solely on the basis of an algorithm, that gives rise to concerns, and that gives rise to the need for ethical implementation and safeguards by ethical humans. I think perhaps, in my view, it is easier to develop those safeguards than some who have raised those concerns might suggest, because I think most of those safeguards are a matter of will rather than of us not inadvertently missing something. So if we want to have a situation where ethical humans remain in control of key decisions, I think we could. It's a matter of policy more so than anticipating every single possible contingency. Now, it's interesting, too, that you do agree that inner experience, the subjectivity that we have as humans, can't really be produced by any AI system that currently exists or on the horizon, and we don't quite know the criteria for the emergence of that inner experience. I think it will become increasingly apparent over the coming years that intelligence and consciousness are not the same. And you can have an intelligent system that is not conscious, which is what a lot of the, at least near-term AI systems are going to be. But it will be a very important question: when can consciousness potentially emerge, even in systems that don't have a biological substrate? And I think that question is going to consume the attention of a lot of philosophers in the coming decades. But in the meantime, we're not close to that yet. And I think it's good to have that as an area of agreement about what the distinguishing human attributes are going to be. As for the others, I think, well, extraordinary claims require extraordinary evidence to invoke that common statement. So I am open to the evidence. I am open to the demonstration of an AI system that can exhibit these attributes that I think humans excel at, or sometimes even have exclusively at present. And it could be a matter of degree. So as with common sense, some AI models today can simulate it, but humans are still better at it because we have more inputs, both from our sensory experiences and other humans, to indicate what a common sense decision would be. Can AIs improve at that? I would say probably. But can they ever improve to the point that they would surpass us? That's where I have doubts. And I will also state a more fundamental doubt. I'm not sure with the current architecture of AI systems that we can get to an artificial superintelligence in the way that is posited as being necessary to reach the AI singularity. Because if you give an AI system all of the training data that exists currently, so that's all of the knowledge of humankind that has been accumulated and written down somewhere or somehow recorded, will it still be smarter than the smartest human who just has incredibly fast recall of information and higher processing capabilities? So yes, that would be an impressive individual if such a person existed. But can we really reach like a qualitatively higher gradation of intelligence with today's AI architectures? That's where I have my doubts. So could these AI systems be the equivalent of, say, Stephen Hawking's or Albert Einstein's among us, again, with much faster computing capabilities? Sure, they could. But Albert Einstein and Stephen Hawking didn't make the human species obsolete. They just made valuable contributions to human knowledge. Unfortunately, they weren't even able to alter the course of history beneficially to the extent that they had hoped. So, yes, it would be great to have these entities among us, but I think the rest of us will still be necessary.
One very quick follow-up to that. We both know, Gennady, about a particular AI agent called Aubrey, which has been trained on the findings, writings, and ideas of Aubrey de Grey. And Aubrey de Grey himself has said that some of the responses of the bot are surprisingly intelligent, coming up with ideas that was not in his mind. In other words, this bot had all the same attributes of Aubrey de Grey, or many of the same attributes, but had access to more training information, read more articles. And so Aubrey already feels in some cases that his own research may be accelerated by the assistance of this agent. And what we need to get to the singularity is simply that the software engineers who are currently designing the next generation of AI, that their work will go much faster because of simulations of them and their working environments. So the key point is when we have companies like OpenAI or whatever who are able to unleash one generation of AI to help them design much more quickly the next generation of AI. And once that's in place, it will allow them to get much closer to general intelligence. So that's the tipping point. Are we seeing signs that it's coming? Well, even people like Francois Chollet, who you mentioned and who is a real gem. I saw him give a talk in Seattle just over a year ago at the previous AGI conference, in which he did outline the ARC AGI challenge. And he said here are various things that he didn't think AIs would solve anytime soon. Since then, he has gone on record and saying he has revised down his timelines. I put in the chat a conversation between him and Dwarkesh Patel. Dwarkesh Patel is probably the best podcast now on what's happening in AI. He does it very well. And Francois emphasizes there that he's reduced his timelines, not to 2027. He says probably about 5 years out. So he is seeing AI solve some of the problems more quickly than he had thought possible. There's the evidence that things are still making significant progress.
Yes, that is fascinating. Thank you.
Thank you. I think that we have to stop the discussions. We spent a lot of time. So thank you very much, Gennady.